let's say we have t squared over t minus 7 minus 5t plus 14 over t minus 7. Well, t minus 7, we're subtracting. We know we leave t minus 7. On the top, t squared minus the entire 5t plus 14. Distribute the negative. T squared minus 5t minus 14 all over t minus 7. We'll go to factor. We need numbers that multiply to negative 14 and add to negative 5. These are negative 7 and positive 2, minus 7 plus 2. The t minus 7s cancel, and we're left with t plus 2. So that's how we take care of adding and subtracting rational expressions that have a common denominator, that already have the same thing on the bottom. Now, if you remember how we add and subtract fractions that don't have the same thing on the bottom, that don't have common denominators, you might be thinking, well, this is going to get interesting. And guess what? This is going to get interesting. Objective 2 in this topic: identify the least common denominator of rational expressions. So this seems to be going the same way learning fractions did. First, we learned how to simplify fractions, reduce. Then we learned how to multiply and divide fractions. Then we learned how to add and subtract with a common denominator. Then we learned about least common denominators. And just like with fractions, to add or subtract rational expressions with unlike denominators, we first have to change them to equivalent forms that have the same denominator, or a common denominator. This involves finding the least common denominator of the two original rational expressions. So the steps for finding the least common denominator: first, no surprise, factor each denominator completely. Factoring keeps returning as a necessary skill with rational expressions. The LCD, the least common denominator, is the product of all unique factors raised to a power equal to the greatest number of times that the factor appears in any factored denominator. So all unique factors raised to the highest power shown. So let's find the LCD of the rational expressions 1 over 6y and 3x over 4y plus 12. Well, we need to completely factor the denominators. 6 can be represented as 2 times 3, so 6y is 2 times 3y. 4y plus 12, we can factor out a 4, which leaves us with y plus 3. And 4 can be represented as 2 times 2, or 2 squared. Each unique factor we have here is a 2, a 3y, and a y plus 3. The highest power of 2 that we have is squared. The highest power of 3y that we have is just 3y. The highest power of y plus 3 that we have is just y plus 3. So 2 squared times 3y times y plus 3 would be the least common denominator. And we can simplify that. 2 squared is 4. 4 times 3 is 12. So 12y times y plus 3. Another one. Now let's look at 4 over x squared plus 4x plus 3 and 4x minus 2 over x squared plus 10x plus 21. We need to factor the denominators. So for x squared plus 4x plus 3, we need numbers that multiply to positive 3 and add to positive 4. That's positive 3 and positive 1. For x squared plus 10x plus 21, we need numbers that multiply to 21 and add to 10. That's plus 7 and plus 3. Each unique factor is x plus 3, x plus 1, and x plus 7. They're all only raised to the first power everywhere we see them. So the LCD is x plus 3 times x plus 1 times x plus 7. Don't get confused and think the x plus 3 is squared because we have 2 of them. The only thing that second x plus 3 does, since it's in the other denominator, is get skipped because it was already included. Let's find the LCD of the rational expressions. 3x over 5x squared minus 5 and 4x squared over x squared minus 2x plus 1. Again, factor the denominators. When we factor 5x squared minus 5, we can factor out a 5, leaving us with x squared minus 1. And x squared minus 1 is a difference of squares. Thus, it factors to x plus 1 times x minus 1. X squared minus 2x plus 1. We would need numbers that multiply to 1 and add to negative 2. If you're having trouble finding them, it's because they're the same number. Negative 1 and negative 1. X minus 1 times x minus 1 is x minus 1 squared. So you might have also noticed that was a perfect square trinomial and factored accordingly. Each unique factor we have would be 5, x plus 1, and x minus 1. The highest power of 5 is just 5 to the first. The highest power of x plus 1 is x plus 1 to the first. The highest power of x minus 1 is x minus 1 squared. So our LCD would be 5 times x plus 1 times x minus 1 squared. Are we having fun yet? We're doing it again. This time we have 1 over x minus 3 and 2 over 3 minus x. Remember, these aren't the same. They're opposites. But if we multiply one of them by negative 1, we can get them to look the same. However, we don't want to change the value. So if we really wanted to change, say, the 3 minus x to x minus 3, we would have to multiply by negative 1 over negative 1 because that's 1, and that wouldn't change the value. So that second rational expression could be negative 2 over the opposite of x minus 3. Now, we don't need to do any of that because we're just looking for an LCD. But the reason I point all that out is that x minus 3 is kind of hiding in 3 minus x. And 3 minus x is kind of already hiding in x minus 3. So since each is the opposite of the other, and the other is hiding in each other, sort of, we can use either one as the LCD. The third objective in this topic is adding or subtracting rational expressions with unlike denominators. So now that we know how to find a common denominator, just like with fractions, we're now able to add or subtract rational expressions that have unlike denominators. Find the LCD, write each rational expression as an equivalent rational expression whose denominator is the LCD found in step 1. Then add or subtract the numerators, write the result over the denominator, and simplify if possible. So let's add. 15 over 7a plus 8 over 6a. We're adding, we do not have the same denominator. We need a common denominator. We look for the common denominator of 7a and 6a. The individual factors are 7, 6, and a. They're all to the first power. So 7 times 6 times a is going to be the common denominator. We need to multiply the first fraction by 6 over 6. We need to multiply the second fraction by 7 over 7. That will accomplish 6 times 7a, or 42a. 6 times 15 gives us 90. 7 times 8 gives us 56. We have a common denominator now, so keep that common denominator and add across the top. 90 plus 56 is 146. And we can divide 146 and 42 both by 2, leaving us with 73 over 21a. Now, I slipped earlier and I accidentally referred to these as fractions instead of rational expressions. But was I wrong? This is just adding fractions with unlike denominators. This one is just subtracting fractions with unlike denominators. Before we do this problem, I do want to correct myself. Earlier, I said that we could multiply top and bottom by -1 because that's -1 over -1, and that doesn't change the value. What I should have said is that we can factor out a -1 from the bottom. That also wouldn't change the value, and it's a lot more straightforward than multiplying by -1 over -1. Why do I bring that up now? The opposite problem, because we have opposites here in the LCD. And we can turn them into the same denominator if we factor a -1 out of the bottom right. Factoring a -1 out, that -1 can then mix with the minus sign, turning it into a plus sign. 5 over 2x minus 6 plus 3 over 2x minus 6. So we factor a -1 out of the bottom, and then minus that -1 becomes plus. Add across the top, 8 over 2x minus 6. We can factor a 2 out of the bottom, And 8 is 2 times 2 times 2. So that 2 we factored out on the bottom cancels with one of the 2's on top, leaving us with 4 over x minus 3. Once again, we're adding two rational expressions. They don't have the same denominator. We need a common denominator. In order to find that common denominator, we need to write this completely factored. To factor the bottom left, we need numbers that multiply to -6 and add to -1. Those numbers are -3, +2. And then to factor the bottom right, we need numbers that multiply to 6 and add to 5. Those are 3 and 2. Examining the individual factors we have on the bottom, the unique ones are x minus 3, x plus 2, and x plus 3, all to the first power because they only appear in their respective denominators once. So we need to rewrite both of these with that common denominator. The first denominator was just missing the x plus 3, so we multiply by x plus 3 over x plus 3. The second denominator was just missing the x minus 3, so we multiply by x minus 3 over x minus 3. Then we add across the top, keep the denominator, the common one. And we have 4 times x plus 3 plus x times x minus 3. We would need to distribute the 4x plus 12. Distribute the x squared minus 3x. When we add those together, 4x plus 12 plus x squared minus 3x. Combine like terms. Maybe rewrite the order so that it looks like a polynomial we're used to that starts with x squared and ends with the constant. So x squared plus 4x minus 3x would be plus x plus 12. X squared plus x plus 12. Now, if there were numbers that multiplied to positive 12 that added to positive 1, there aren't. If we could factor it, we would have to factor it just to make sure that none of those factors in the denominator cancel. But x squared plus x plus 12 does not factor, let alone factor into something that has one of those factors in it. For instance, if we had 1/3 plus 1/6, we can't add these, not yet, because they don't have the same number on the bottom. We can't add thirds and sixths when they are thirds and sixths. But what we can do is find the least common multiple of 3 and 6, which would be the least common denominator of these two fractions. So the least common denominator of 1/3 and 1/6 would be the least common multiple of 3 and 6. How do we find least common multiple? Well, we skip count. 3, 6, 9, 12, etc. 6, 12, 18, 24, etc. And the first number in common is 6. The least common denominator of the two fractions, the least common multiple of the two numbers, is 6. That means we want to rewrite both fractions as sixths. The second fraction was already sixths. It was 1/6. We can just copy that down. We can't just put a 1 here because 1/3 is not 1/6. We have to ask ourselves, what did we multiply by? 3 times what is 6? Well, 3 times 2 is 6. So we do the same thing with the top number. 1 times 2 is 2. And then 2/6 plus 1/6 is 3/6, which we would then reduce to 1/2. Now there's another way to get least common multiple, and we'll do it with 3 and 6 first, but that's not so interesting. Remember that when we found greatest common factor, we were factoring things out. Greatest common factor is you take every factor common to both to the lowest power shown. So greatest common factor, we take common factors to lowest powers. For LCM, we're going to kind of do the opposite. Instead of just the factors in common to everything, we're going to take all factors, and instead of to the lowest power, we're going to take them to the highest powers. So 3, its prime factorization is just 3. 3 to the first. 6, its prime factorization is 2 times 3, or 2 to the first times 3 to the first. So every factor we would have, we have a 2 and we have a 3. And the highest powers we have of each of them are just the first. That gives us our 6. Let's use this method of finding the common multiple, which is how we find the common denominator, to do 1/20 plus 1/8. The long way of finding these multiples, we would have to skip count on 8s. 8, always start with the number itself. 8, 16, 24, 32, 40, and so on. 20 would be 20, 40, 60, and so on. And that first number in common is 40. So we know our common denominator is going to be 40. Let's use this other method, because the other method is going to be the rules we follow for the polynomials. Factor. Let's take the prime factorizations. If we do factor trees, we end up finding that 8 is 2 times 2 times 2, or 2 to the third. Two to the third. 20 4 times 5, 5's prime. 4 is 2 times 2, those are prime. So 20 is 2 times 2 times 5, or 2 squared times 5. Let's do our rule. Every factor to the highest power. We have a 2, we have a 5, The highest power of 2 we see is a 3. The highest power of 5 we see is just 5 to the first. That's 8 times 5, which is 40. So the least common multiple of 8 and 20 is 40. That means the least common denominator of 1/20 and 1/8 is 40. Which means both of these fractions need to be rewritten as fractions over 40. So neither of them were originally 40. That means that we can't just write a 1 for either of these. We need to figure out what are we multiplying by. 8 times what is 40? 8 times 5 is 40. So 1 times 5 is 5. Again, we're not putting a 5 here just because it's multiplying by 5. We're putting a 5 here because it's multiplying by 5, and 1 times 5 is 5. If this was 2/8, we would multiply the 2 by the 5 and get 10. 20 times 2 is 40. 1 times 2 is 2. 2 40ths plus 5 40ths is how many 40ths? 2 plus 5 makes 7 of them, and that does not reduce. 7 40ths. Let's do a little bit more work just finding LCD. Let's not add or subtract any of these since we're building up to a bigger problem. Let's find the LCD, least common denominator, of 1/12, 5/18, and 7/30. To find the LCD of those three fractions, we would need the least common multiple of the three denominators of 12, 18, and 30. Let's find the prime factorizations, doing our factor trees. 12 would be 3 times 4. 4 is 2 times 2. 12 would be 2 squared times 3. Doing 18, 3 times 6. 6 is 2 times 3. 18 is 2 times 3 squared. 30, that's 3 and 10. 10 is 2 and 5. 30 is 2 times 3 times 5. So least common multiple, every factor we have 2s, we have 3s, and we have 5s. To the highest powers shown, highest power of 2 is 2 squared. Highest power of 3 is 3 squared. Highest power of 5 is 5 to the first. That makes this 4 times 9 times 5. That makes this 180. So if we didn't do this way, we would have to skip count out on the 12s all the way out past 180. We would have to skip count the 18s all the way past 180. And we would have to skip count the 30s all the way past 180 to the point where 180 is the first number in common to all three lists. That's why it is the least common multiple. That means if we were to add or subtract these, we would need to write them as equivalent fractions with 180 in the denominator. Now let's relate this to expressions. Let's find the least common denominator of 1 over 2x cubed y and 5 over 16xy squared z. Now this looks way more complicated, but really it's not. We're going to do what we did with finding the least common multiple of 2 and 16. And since the skip count list for 2 would include 16, we just know that's going to be 16. Otherwise, 2 is 2 to the first, 16 is 2 to the fourth. Only factor we have is 2. Highest power of that is 4. And 16 is that 2 to the fourth. But we also have x's, y's, and z's. So we got the 16 from the number part. Every variable factor that we have makes it in. So we get an x, we get a y, we get a z to the highest powers of each. Highest power of x is x cubed. Highest power of y is y squared. And the highest power of z is just z to the first. So that's our least common denominator, 16x cubed y squared z. What's that? You want one more of these? Okay. And let's actually add these two. For fun. Let's add 1 over 9 a cubed b squared plus 5 over 18 a to the fourth b. We need a common denominator to be able to add these. So we need the least common multiple of the two denominators. We need the least common multiple of 9 a cubed b squared and 18 a to the fourth b. Well, 9 and 18 is going to be, let's do prime factorizations. If you see it's going to be 18, that's great. I just want to keep using the rule consistently throughout. 9 is 3 squared. 18 is 2 times 3 squared. So every factor we have to the highest power. We have a 2. We have a 3. The highest power of 2 is to the first. The highest power of 3 is squared. We also have A's and B's. The highest power of A is a to the fourth. The highest power of B is b squared. So this is 2 times 9, a to the fourth b squared, 18, a to the fourth b squared. So that's the least common denominator. Watch what we do, because we haven't done one like this yet. We're going to rewrite each of these fractions so that they have both denominators of 18a to the fourth b squared. 18a to the fourth b squared. Now on top here, we're going to write 1 times something, and we're going to write 5 times something, because when we do the equivalent fractions, remember, we ask ourselves, what do we multiply from to go from here to here? What do we multiply from to go from here to here? And then we multiply the top by those things. That's what we're setting up. The top, 1, times, it's going to be whatever we get, whatever we have to multiply this by to get this. So 9 times what is 18? 9 times 2 is 18. A cubed times what is a to the fourth? Well, we need another a cubed times a. B squared times what is b squared? We don't need anything else. We got the b squared. So the 1 is just going to be multiplied by a 2a. Here, 18 times what is 18? We already got it. A to the fourth times what is a to the fourth? We already got it. B times what is b squared? B times b. So this is 1 times 2a. 2a over 18a to the fourth b squared plus 5 times b. 5b over 18a to the fourth b squared. We have the same thing on the bottom now. Now we can just go ahead and keep that same thing on the bottom, 18a to the fourth b squared. This would be the next line underneath. I ran out of room, so I'm just writing the answer up here because we are at the answer step. Same denominator, keep the denominator, add across the top, 2a plus 5b. No, you cannot cancel here. You cannot cancel here because the top says 2a plus 5b. If it was times, then yeah, have at it, start canceling. Canceling is something that can only be done when everything is factored and written as multiplications. Here we have the 18 times the a to the fourth times the b squared, but those are only eligible to factor with the entire 2a plus 5b. And since we don't have a 2a plus 5b on the bottom, we can't cancel any of that away. That is our simplified final answer. Let's do another addition of unlike ones with simple denominators. Let's take a look at 3 over 7b plus 4 over b squared. So first, what's the LCD? The LCD is going to be the least common multiple of 7b and b squared. The least common multiple of 7 and 1, since we don't have a coefficient here, is just going to be 7. We have a b, and the highest power of b we have is squared. So 7b squared. is our least common denominator. Set up 3 times. Set up 4 times. 3 times what? Well, 7b times what is 7b squared? Well, 7b times b is 7b squared, so 3 times b is 3 times b. Same over here. B squared times what is 7b squared? Well, times 7. So the top would also be 4 times 7. This gives us 3b over 7b squared plus 28 over 7b squared. And this is 3b plus 28 all over 7b squared. Can we factor anything out of the top? No, this cannot possibly simplify any further then. Again, four over 5y plus 1 over 3y cubed. The least common denominator is going to be the least common multiple of 5y and 3y cubed. Least common multiple of 5 and 3 is 15. We have a y, and the highest power of y we have is 3. So 15y cubed is going to be the common denominator. Set up 4 times, 1 times. 5y times what is 15y cubed? 5y times 3y squared would be 15y cubed. 5 times 3 is 15. Y times y squared is y cubed. So just real quick before we do this side, why does this work? Well, it works because we take our original 4 over 5y and we end up multiplying by, in this case, 3y squared over 3y squared, which is 1. It doesn't change it. That gives us 12y squared over 15y cubed. And that's what we're going to get here. The 4 times 3 gives us the 12y squared. So it's because we're multiplying by a form of 1 that is designed to give us the common denominator we want. Over here, 3y cubed times what is 15y cubed? We just need the 5. 3 times 5 gives us the 15. We already have the y cubed. So 12y squared over 15y cubed plus 5 over 15y cubed gives us 12y squared plus 5 over 15y cubed. Nothing factors, and therefore nothing cancels. Okay, we're going to look at more complicated ones now. What would be the least common multiple of these two expressions? The least common multiple of x squared plus 9x plus 20 and x squared plus 8x plus 16. Well, up until now, every time we've found a least common multiple, we have looked for every factor we have to the highest power. We don't see factors here. These aren't factored. So we have to factor each of them. X squared plus 9x plus 20, we need numbers that multiply to positive 20, that add to positive 9. These are plus 4 and plus 5. So that's the factored form of x squared plus 9x plus 20. If we factor the x squared plus 8x plus 16, this is a perfect square trinomial. It ends up factoring as x plus 4 squared. So the least common multiple is going to be every factor we have. We have an x plus 4. We have an x plus 5. We already have an x plus 4. The highest power of x plus 4 that we see is x plus 4 squared. The highest power of x plus 5 we see is x plus 5 to the first. So that would be the LCM here. Least common denominator of two fractions that have these on the bottom would be x plus 4 squared times x plus 5. Let's use this. And we'll do a subtraction problem. 3t minus 2 over t squared plus 4t minus 12 minus the fraction 5 over 2t plus 12. Well, don't panic. What do we do first? We have to find a least common denominator. Since we're going to need the factored forms to do that, our first step in factoring, or our first step in adding or subtracting when we have things that factor on the bottom, is going to be to rewrite with factored denominators. Factor the bottom of both of these. And this one's easiest because we can factor out a 2, and we're left with t plus 6. Over here, we would need numbers that multiply to negative 12 and add to positive 4. These numbers would be plus 6 and minus 2. So this is t plus 6 times t minus 2. So let's look at everything we have, and let's find the LCD. Every factor we have a factor of 2. put the number first. We have a factor of 2. We have a factor of t plus 6. We already have a t plus 6. We have a factor of t minus 2. So every factor we have to the highest power shown, highest power of t plus 6 that we see is just the first, highest power of t minus 2 that we see is the first, highest power of 2 is the first. So this is the LCD. I'm going to go ahead and move this up so that I can do the work. Okay, so I've just given myself more room. The LCD has to be 2 times t plus 6 times t minus 2. So both of these fractions need to be rewritten with 2 times t plus 6 times t minus 2 on the bottom. I told you knowing the fraction rules was going to be important, because if you know how to add and subtract fractions, these rules should be making sense to you right now. You should be able to see we're just doing the same thing as fractions. If fractions were a weak point for you, you're probably struggling right now. And there's nothing I can do except say, keep practicing. There's nothing I can explain more. This is the explanation. I'm not holding anything back from you. It's not like if you email me later and say, hey, I don't quite get this. There's nothing I can say that I'm not saying now, which means that my answer to that email would likely be sending you back to the lecture. And I'm sorry if that feels like I'm brushing you off or, just telling you to look again, but I can't just say it all again. Now, if you send me work and you go, I don't understand where I went wrong here, I got the wrong answer, I'm glad to help you find your mistake there and explain how to do that correctly. But you need to provide me with a work sample to correct and to see what you're doing wrong. If you just send me a message that says, hey, I don't get this section, I don't know what I'm supposed to do with that. And I don't know what you expect me to do with that. But send me actual work and I will help you with that. The work can't be, here's a problem and here's a question mark. I don't know what to do. I need to see what you're doing. Okay. So our strategy here is going to be a little bit different. Because again, I want to give you the easiest way to do these. And if you set this up like this, you're going to notice that there are some factors on the new bottom that were already in the original bottom. So let's set up our 3t minus 2 times whatever that's already there, and our 5 times whatever. And we're going to take the missing pieces and add them in. Not add, not plus. We're going to multiply them in, but we're literally just going to fill them in. So did we have a 2? No, that means we need a 2 times 2. Did we have a t plus 6? Yes, so we don't need it. Did we have a t minus 2? Yes, so we don't need a new one. Basically, we've now multiplied this original fraction by 2 over 2, multiplied it by 1. It didn't change the value, but it gave us the common denominator that we need. Moving over here, the 5 that was originally up there, times our missing factors. We have a 2. We already had a 2, so we don't need a new one. T plus 6, we already had that. We don't need a new one. T minus 2, we did not have that, which means we put it in. So again, look, this T minus 2 over T minus 2, that is a factor of 1 that we're multiplying by the original. Here, this 2 over 2, that's a factor of 1 that we're multiplying by the original. 3t minus 2 over that stuff. Okay, so we're subtracting two fractions that have the same denominator. That means our answer will also have that denominator, 2 times t plus 6 times t minus 2. On top, we have 2 times 3t minus 2. That's what we get when we multiply the 2 times that. And then we are subtracting the 5 times the t minus 2. We need to be careful here. We're subtracting the 5 times the t minus 2. We're subtracting that whole thing. Remember, when we subtract, be careful, because when we subtract this numerator, we are subtracting the whole thing. We need to group that. We need to make sure we're subtracting the entire thing. I'm going to move this up. Move this up here to continue working. I'm not going to make any changes. 2 times 3t minus 2 minus the whole 5 times t minus 2. You might be thinking, how much more work is left in this problem? Oh, you sweet summer child, there is so much work left in this problem. Okay. Now we got to simplify the top. Eventually, we need to see if it factors, if we can cancel stuff. But before we can do that, we've got to multiply it all out so that we can see the thing that we are attempting to try to factor. So we got to multiply it all the way before we can see if it factors, before we can see if things cancel. So bottom's going to stay the same. Keep the bottom factored. We are only worried about multiplying out the top. We need to see everything in factored form at the end, so always leave the bottom factored. On top, distributing the 2. 2 times 3t is 6t. 2 times negative 2 is negative 4. Then we will be subtracting this whole thing. And that whole thing, 5 times t is 5t. 5 times negative 2 is negative 10. Now, we can distribute this negative. We still have 2 times t plus 6 times t minus 2 on the bottom. On top, 6t minus 4, and then minus 5t plus 10. Negative times negative is positive. Combine the like terms, keeping the 2 times the t plus 6 times the t minus 2 on the bottom. We get 6t minus 5t is just a single t. Negative 4 plus 10, that's positive 6. And this is what I was talking about before. We can't just cancel a t. We can't just cancel a 6, perhaps with this 2. Because this t plus 6, that's 2 things added together. That makes it one single factor. And that single factor of t plus 6 multiplies with that single factor of t plus 6. The t plus 6 goes away. We're just left with 2 times t minus 2 on the bottom. And there's nothing left on top. Again, is that 0? No, because anything has a times 1 with it that we just can't see. We are left with 1 over 2 times t minus 2. Leave the denominator in factored form. Fun, right? Let's do another. You say, what are you doing? Why are you writing a third thing? Do you hate me? I don't hate you. I want you to be able to get these things right. That's why I'm showing them to you. X squared plus 3x. 3x plus 18. Okay. We're adding and subtracting 3 of these things now. Wonderful. Doesn't change what we do. Get a common denominator on the bottom, add and subtract across the top. So, first step, factor anything that we can in the denominators. Don't worry about the numerators, just the denominators. X doesn't need to factor further. X plus 3 doesn't need to factor further. That one can. Does it seem like a waste to rewrite everything without changing it in 5 different areas only to end up factoring out an X here, this being the only change? It might seem like a waste, but it's not. Write it down. It is its own step. If you need to condense steps because you're running out of paper, you need to get more paper. Don't skimp on what you're writing. I have had conversations with students where I'm looking at their notes and I'm saying, you're fitting it all in on the front of 1 page and other people are submitting 7 pages of notes. You have to change what you're doing. And instead of listening to me, I get a response back of, well, that's just how I've always taken notes. If you're not going to take the advice of the teacher whose profession it is to teach hundreds of students per semester how to do this stuff, that is your decision. It's not a good decision, but I'm not going to pull teeth and drag you across the finish line and make you do things a certain way if you insist on doing it your own way. But I'm telling you that if you want to be successful, you got to write out all your steps. You might be able to handle it now. You will hit a point where you hit a wall because you're trying to do too much in your head at once. Or in these examples, you're not writing down every step that I'm doing. I'm not writing out all these steps just so you can see, hey, here's how he goes from that one to that one. There's all this stuff in between. Oh, I'm doing it because if I'm writing out the step, then so should you. This is not to make you see how it's being done. This is how it's done. Sorry, no more rants. We're so close. So what have we done? We've factored the bottom of the third one. Now we find an LCD. The LCD is going to be every factor we have to the highest power we have. We have a factor of x. We have a factor of x plus 3. We already have the x. We already have the x plus 3. Highest power of each is just the first. So the LCD is x times x plus 3. So now we have 3 fractions, and each of them needs to be x times x plus 3 on the bottom. X times x plus 3. X times x plus 3. And since that one, the third one, didn't change, we can just go ahead and put our 3x plus 18 up there. That one's done. That one hasn't changed at all. Here, we're going to multiply the 2 by something. Here, we're going to multiply the x by something. By what? We're going to look at the bottoms and see what we have now that we didn't have before. And if we didn't have it before, we need to throw it in as a factor on top. X, we already had. X plus 3, that's new. So why did we end up putting that in? Well, because we had originally 2 over x. We can multiply that by any form of 1 and not change it. And this specific form of 1, x plus 3 over itself, is the one that gives us x times x plus 3 on the bottom, the LCD. So that's why this works. Here, don't be confused with this x and put an x plus 3 in. The x is this x that's already here. Ignore the top for now. We're looking at the bottom. We have an x times x plus 3. We already had the x plus 3. We need an x. So here, there's our original. The x over x plus 3, that's our original. We're multiplying it by x over x to give us x times x plus 3. I'm hoping that if you hadn't clicked so far, that did the clicking for you. Okay, moving this up top, not changing anything. I just need more room. 2 times x plus 3 over x times x plus 3 plus x times x over x times x plus 3 minus 3x plus 18 over x times x plus 3. See how we're going to be subtracting this fraction, which means subtracting that whole numerator. Let's go ahead and put in our parentheses now, because we're going to be careful because of that minus. We don't want in the long run to write minus 3x plus 18. That's not right. We want to be able to write minus this entire thing. Okay, continuing. We have x times x plus 3 on the bottom. In all 3, that is our common denominator. That will be the denominator of our answer. Up top, we have 2 times x plus 3 plus x times x, which is x squared, minus this whole 3x plus 18. Keep the bottom in factored form, but now we have to expand the top. Distribute the 2. 2x plus 6 plus x squared minus 3x minus 18 all over x times x plus 3. Looking at like terms, combining, we have our positive x squared. We have positive 2x minus 3x, that's minus x. We have positive 6 minus 18, that's minus 12. I'm going to move that up to the top. X squared minus x minus 12 all over x times x plus 3. We got to factor that top now. X and x, we need numbers that multiply to negative 12, add to negative 1. That's plus 3 and minus 4. Put in x plus 3. Put in x minus 4. The x plus 3's cancel, and we are left with x minus 4 over x.